Coming up on this episode of the IoT Inc. Business Show.
It's the domain expertise, it's the applications, it's knowing how to apply the analytics packages, or then the core computing and plumbing infrastructure, and even I would say to some degree the analytics tools themselves. There's a lot of them. Some of them are better suited than others for our problems, but we don't see in our industries long-term differentiation from package A to B to C to D. And I might be making people unhappy by saying that, but that is our perspective.
There are two types of manufacturing. Discrete manufacturing, where the output is physical, countable things, and process manufacturing, where the output is chemistry. Think oil and gas. Process manufacturing has been consistently instrumented over the last 2 decades, so it's not surprising they're a little bit ahead of their discrete counterparts on the path to IoT. In this episode of the IoT Business Show, I speak with Peter Zornio about IoT analytics and process manufacturing, and his advice is applicable to all industries.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com. With me today on the IoT Show is Peter Zornio. Peter is Chief Strategy Officer for Emerson Automation Solutions. He's responsible for coordinating the tech, products, and industry standards across the automation group. He's been at Emerson for 10 years, and prior to that, he was at Honeywell for 20 years. Peter, welcome.
Hi, Bruce. Thanks. It's great to be here with you today.
So, automation solutions and not IoT solutions?
Okay, good question. So, in the process industries that we serve at Emerson, which are industries like the oil and gas industry, chemicals, refining, for a long time we've used digital systems to control those facilities.
Sure.
And if you were to look at the architecture of one of those, well, it looks a lot like what today we call an IoT architecture. It's just that it's typically local to the facility itself that we're controlling. So, we feel we have a lot of background and experience in kind of the fundamental architecture and applications and design that goes into what today people, view as IoT solutions in terms of real-time sensors feeding data to applications or experts, coming up with specific actions and things that need to be taken place. So for us, in those industries that we serve, this whole idea of IoT, we view that more as kind of an evolution than a revolution of what we've been doing. And, I think that's very different than a lot of the other IoT industries that you talk to and are discussed frequently, like homes and buildings and cities and parking lots and, and people, right? Instrumenting people and feeding data from them to applications. That's that fundamental architecture of a closed loop kind of circle of data with applications to action. That's what we do in the automation space and have done for 40 years.
So automation, I guess, is what you're saying is something that your customers are comfortable with. And I'm surprised that you're not jumping on the IoT bandwagon, if nothing else, even if it is the same. Who cares? I mean, it's just like marketing, right? You just say IoT and all of a sudden it increases your stock price and you can then circle a different, put a circle around a different part of your business. All of a sudden that part of your business is growing quickly. I'm surprised you guys haven't jumped on that bandwagon.
Well, we absolutely have. As a matter of fact, actually, at our big customer event that we host every year. Last year happened to be in Austin. We did an announcement of kind of our overall strategy around IoT. We always talk about IIoT, industrial IoT, and we call that plant web. And we talked about it as kind of the technology underpinnings for fueling operational performance at all of these facilities.
No, that makes sense. Now, clarify for me, Peter. I mean, and I think you brought up a good distinction in the automation world. A lot of this has been happening. I mean, and I would say if it's advanced, and it sounds like what you guys were doing was advanced, there would be a local area network. Sometimes it's like a sneaker net, it's M2M. But would you consider this M2M, or would M2M even be? I guess you can look at it a few different ways. But have you been doing M2M all this time since it's been local, or is it still different from what you're calling automation?
Oh, you'd call it M2M, what we've been doing all this time. Yeah. The M2M terminology, that exact term, actually, and this is kind of a subtle difference, but is something that really more the discrete manufacturing industry has used a lot. People that do things like make cars, or where they machine or manufacture stuff with mechanical processes. In the process industries where you're using chemical processes and flows and things are more around chemical reactions creating or splitting things. We've been doing it. It's just funny that term never caught like it seemed to in the discrete manufacturing. But if I were to describe to you specifically what we did, and have been doing for 40 years, you'd say, "Oh, that's M2M," and you'd be right. Okay, so we just, for whatever reason, it's funny that term didn't make its way into the process side of manufacturing as much as it did into the discrete side.
Interesting. No, I didn't know the difference. I didn't realize the subtle difference, but that now that you mention it, it's true. When I hear certain industries talk about it, they'll drop M2M more often. But sometimes they're even getting rid of the M2M, right? I mean, they're getting rid of the M2M because
M2M. Hey, it's, as you just said, it's way more catchy to talk about IoT now than M2M, right? So
yeah, for sure. So let's go back. This is kind of a becoming a game, I suppose, with all my guests, and the game is, how far back have we actually been working in IoT /M2M /automation? So tell us a little about yourself and your background in IoT.
Okay. So, my background in automation is, as you just said before, over 30 years now.
Okay. And doing it the whole time? You've been doing automation for those 30 years?
Yes, I'm a career automation guy with basically two companies, as you went through. Honeywell and Emerson, actually, two of the biggest companies in the process automation space. Always in the a combination of the sensor and really more on the digital systems kind of side. So how do we pull that information in? How do we analyze it? How do we how do we display it for operations personnel so they know the correct actions to take? Algorithms. I say algorithms. There's another one now. Now you have to say analytics, because that's the IoT term. Showing my age there. But analytics and algorithms and software processing of that information to come up with actionable results. I mean, that's what we do. But historically, in the automation business, what we've done that with really one primary goal, and that is the safe and reliable operation of the actual processes inside of the facility, right? So, the focus has always been on running the plant and running the processes. In the IoT world, and more recently, I'd say in the last 5 to 8 years, we've been looking at, how do we do other application domains inside of these processing facilities? So yes, we need to make sure that the process is running safely and securely and reliably. Reliability is everything in a lot of these plants in terms of their profitability, because they can take a long time to restart and operate properly. And while they're down, they're not producing any revenue. So we started looking at other areas like reliability itself. So monitoring the equipment itself, which is, of course, the number one example I would say for sure the number one example you always hear talked about in industrial IoT. Yeah. But we've also done it for areas like energy, where we're monitoring energy consumption around facilities and calculating for customers energy consumption and what and where they could be doing things to decrease it. And even some kind of like safety applications from like personnel safety, like monitoring for hazardous environmental gases or other hazards that might exist in the environment.
Yeah.
So we got a base architecture. I mean, I use the analogy. It's very similar to kind of what happened in cars. You think about cars where, you started out with sensors and computerized systems that controlled the engine, right? And did things like adjust the spark advance and make sure the engine ran properly. And then over the last 20 years, that's exploded into hundreds, if not thousands of sensors on a typical vehicle. And they're doing all kinds of functions, right? They're new safety they're monitoring whether you're in the right lane. They're, monitoring, overall, performance of your gas mileage and telling you what you ought to be doing to improve performance. You have, cameras telling you when your sensors telling you when you're getting close to the curb to help you. So, it starts from that, how do we make sure the core process, in the case of a car, the engine is running properly? And that's what we've done for the process industries for many years. And now what we're seeing is greater sensors, greater applications for other application areas, all of which are around improving operational performance at the facility.
Okay, no, and the evolution in process, I don't know if it's called process engineering or process manufacturing, makes sense because it started out, and I think you've been bringing up monitoring a lot here because providing that feedback. So that feedback initially was to the operator or the operators, and maybe it was just displaying on a screen, not going anywhere. Then maybe we got into what we were calling M2M earlier, maybe along a local network, and then expanding from there. And then you brought up, algorithms versus analytics, and I want to talk about that too. But the first thing is you're calling it the new endeavor Plant Web. Now, you also mentioned safety and reliability. What about when you start getting outside of the plant? Now, we're just going to talk about one aspect of IoT, and that would be the connectivity. And
right.
And that's not the most important part. It's an integral part. But are there applications now where you're going interplant, if that's the right terminology? Are you going outside, or is it still pretty much focused on within the plants themselves?
Well, so you kind of inadvertently just did a good straight man for me there. The reason we call it Plant Web is because literally 20 years ago, we coined that phrase and that term for what we now look back on and say was the intranet of things. The network M2M kind of communication between intelligent sensors and software applications inside of a plant. Okay. And that's why we had that term Plant Web.
Yeah.
Now, of course, when we look at it, we're looking at, the boundaries are the world, right? We're connecting an enterprise. We're connecting plants with other plants, with home office experts, with third-party experts such as ourselves. So we're expanding and connecting across an entire enterprise, and we're looking at other application areas. And we actually debated whether, we should change our terminology or pick a different term. But we actually wanted to stick with that term because, we kind of felt like, well, look, we've been doing things like this for a long time. We were just doing it within the domain of the plant itself. Now we're using the power of the internet to do it across the globe, right? And to connect, not just the customer's internal enterprises, but connecting them with third-party experts and applications such as the ones that we provide.
Yeah. So Plant Web and Planet Web. So maybe there's something. There's something there as well, right? All right, let's talk oil and gas. What's the current state? So what's the current state of the art for IoT? We're going to use IoT in this show. So what's the current state for IoT in oil and gas?
So, above and beyond the systems as I described for process automation, what the oil and gas guys have been doing, the big guys, is over the last, I'd say, 8 years or so, they've been doing what I would call, what I've nicknamed internal IoT. And that is where they've been connecting multiple facilities, offshore platforms, oil fields. They've been connecting those together, bringing that data to centralized monitoring and operating centers. They call those integrated operations centers, and doing what you would look at and call IoT, but they've been doing it within the confines of their own computing infrastructure. I mean, they're using the internet, like everybody does, but they're using their computing infrastructure and behind their firewalls, they're keeping that data contained to their to their corporate systems and, systems that they've put in place in these IOP centers to do monitoring across multiple facilities for reliability, for running analytics on pieces of equipment or analytics on, an oil field, looking at an oil field and matching what they thought was going to happen versus, what actually is happening and adjusting maybe where they're putting wells or adjusting the production of individual wells. But they've been doing that, as themselves. And those are the big guys. Those are the Shells, the Exxon Mobils, the Statoils. Okay. Now, like in many other industries, this new business model, this idea of the connected service, the idea where you would take that data and send it to a third-party expert or a third-party set of applications such as ourselves, that's what's happening now as kind of the big new thing. And, it's progressing at different rates. I'd say the guys that are smaller, so if you were to go to, the West Texas oil fields where there's a lot of small independent operators who don't have a lot of domain expertise themselves in their facilities, they're quicker to go to that kind of a model because it lets them tap into expertise that they don't have. If you go to the big guys, well, the big guys are going to say, look, we have this domain expertise and knowledge ourselves in-house. We don't, we're going to do internal IoT. We're going to continue to connect our network of facilities together, our fleet of facilities together, but we're going to keep most of that in-house. Also see that in the power industry. That's another industry we serve. And the power industries, I'd say, are probably in the process, one of the guys that are maybe even the most advanced, where they've put in these centers and tied multiple power generation stations together and are doing that kind of centralized monitoring.
So let me understand, though. You're saying then what's kind of happening right now is going from what you've termed internal IoT to, let's say, IoT or IIoT. And from my understanding, I'm going to just use the parlays of the current terminology. Up until now, it's been mostly on the local cloud, so on-prem computing, as opposed to putting it externally. So you've been doing it in-house, more or less. But it sounds like you've been doing the same type of functionality. So I'm trying to understand what has been the changes. Is it just that you're utilizing more people? Is it that you're using off-the-shelf software? The industry, when I say you, the industry, or maybe just put a little finer point on it.
Okay. So the change was, as you said, it's been on-prem or it's been customer-owned and operated cloud, right? As part of, so it might be, they might obviously be leasing space from an Amazon or, a Microsoft or whoever, but it's their administered cloud and their people are the only ones with access to the data and it's their people running the applications.
Okay.
Maybe from a centralized center at headquarters in Houston or downtown Dallas or wherever it may be.
Yep.
Okay. But it's been the company's personnel have been the ones operating the applications and analyzing the data.
Okay.
The change, and this is a business model change, is the idea that, we don't really need to have that expertise ourselves and operate these applications ourselves. In certain cases, in many cases, where you're analyzing fairly generic or repeatable pieces of equipment, hey, we can outsource that. We can have, an Emerson or other companies that have that same kind of knowledge and expertise about this equipment. We'll be doing it across multiple customers, maybe have greater scale than we do because they're doing it across multiple customers and even multiple industries, in terms of analyzing data that's coming from a pump or a heat exchanger or whatever the equipment may be. Let them do that for us instead of we do that for ourselves.
Okay.
So that's more of a business model change than it is a technology change because you're moving to outsourcing that function. So an analogy I use there, which others have used, I think, many times is, historically for these companies, we've been technology providers. So we go to them and we supply them with software applications that they will internally host and run on their computing infrastructure to do these analytics. Okay. That's like, in transportation, I'll go back to that. Hey, here's a car. We're going to sell you a car. You're going to get a driver's license. You're going to operate the car. you're going to get insurance. You're responsible for getting yourself from point A to point B. In this new connected service model, basically, you're moving to where we're providing them with a turnkey service. We're saying, look, what you want is high availability in your equipment. We are the guys that can get you that. Just send us your data, okay, and we'll get you high availability. That's more like Uber, right? Hey, I'm here. I'm at point A. I want to get to point B. Uber, get me from point A to point B. You have some control, but not total control over what car shows up, and right. But at the end of the day, you pay them, get you from point A to point B.
Okay. So now this outsourcing that you're talking about, now I'm starting to understand it a little bit better. Is it outsourcing the logistics and the plumbing, so just making sure the trains are leaving the station on time and arriving on time, or is it a little bit more than that? So what is being outsourced versus what is being kept in-house?
So what is being outsourced that traditionally used to be kept in-house is the actual analysis of the data, the running of the software that analyzes the data, and the generation of these are the actions that you should go take to operate better. So here's how you should improve the performance of your plant right now, either the performance of the process or the reliability of the equipment or the energy consumption. It's very much, another analogy would be if you're wearing Fitbits and other smart information on your body, it's having the best doctor at Mayo analyzing that data and coming back to you and saying, Bruce, I looked at your last workout. Let's say that it's the future and they have real-time cholesterol data and they have, all this other wonderful data that maybe today, you'd have to go to the office to get. Here's what I saw in your last workout. Here's what you need to change. Here's what you need to do to get better. Now, historically, that interpretation and analysis of the data was done by the customers themselves. The outsourcing of that analysis and the determination of what the best actions to take to improve, trusting somebody else to do that, that's a big business model change for them. Again, with the car, you trust yourself to drive yourself from point A to point B. With Uber, okay, whoever that Uber driver is, I'm in his or her hands. They're the ones that are going to get me from point A to point B. Well,
to sharpen this up a little bit more, then I can buy into the concept of allowing a third party, like Emerson, to analyze my operational data for efficiency purposes, to try to squeeze out a little bit more efficiency. I'm having a harder time, I guess, nodding my head around other analytics activities. For example, interpreting data to understand where to drill, interpreting data to understand, the methodology or the process methodology, because I would think that would be internal property or intellectual property that these companies would want to keep in-house. So am I on this or off?
You are exactly correct. That is a very astute insight, and that is exactly the situation. Okay. So what is happening is we are finding areas, and we're finding those applications where the customer does not feel that the data that they're going to give us really has much intellectual property value to them. Okay. So if it's, for instance, looking at the vibration waveform of a pump or a compressor, well, that could fall into the hands of any competitor or anyone anywhere, and there's really nothing that they could do or action that they could take with that kind of data, to improve their competitive position or to cause harm, to the end user. The more proprietary, the more you get to the core competencies of what those customers believe they do, the less likely they are to go to this outsource model. So when it comes to, for instance, just as you said, interpreting, seismic data around an oil field and figuring out what's really there and what's not there and where to drill, well, that can swing their entire stock price.
Yeah.
So they're not about to say, well, let's just turn this over, to some third party to do. But when it's, analyzing, hey, the energy consumption around this heat exchanger, tell me when it's fouling and tell me when it should be cleaned. Well, heck, that's not something that, anyone could really, get any advantage on them,
Sure.
by having access to that data. So that is part of what is happening right now is as this market is emerging, as this market is developing, we're figuring out just what are those applications that our clients are ready to have us go do for them that way. What is the data that they're comfortable sending to us? What are the applications that they're comfortable having us do? And I have a very strong belief that at the end of the day, this is all about one thing, and it's about domain expertise. They're going to trust you to do this from an outsourced perspective if they believe you're the guy with the best domain expertise in the area that you're doing this on. Just like going back to my earlier example, that data coming off of your Fitbit, well, who do you want looking at it at the other end of that data? You want the best doctors at Mayo or the best algorithms, running in whatever big data algorithmic system there is to analyze it. That's going to be a big factor in your selection and your choice as to whether or not you'd even consider outsourcing it or not, is whether you believe that person at the other end knows a lot more about what you're trying to do with it than you do, and can be trusted to do it.
Yeah, no, and everyone, this is an important best practice, and it's for organizations that are generally, the enterprises that are generally larger in the processing area. They've had this type of personnel, but sometimes it's seductive when you're a company that's maybe a little bit older school and you don't have this M10 experience or this algorithmic experience to outsource this type of analytics. But Peter's bringing up the point here, and it's a very important one, is domain experience and relating that to your core competency. And so that's why I'm always on, don't reinvent the wheel with the networking platform. Buy a networking platform, and the analogy here is operational efficiency is the same thing. Yeah, okay, what this vibration is and how it works, and that's not your domain of expertise, but you do need to, if it is related to your core competency, if it's more related to how you, even more fundamental, how you generate value, then it has to be something you bring in-house, and if you don't have the people, you need to hire them. And that means you need to hire the software people, you need to hire the analytics people. But I agree wholeheartedly with what you're saying here, Peter, is that for other things such as making sure that the plumbing's working really well and making sure that you can squeeze that extra ounces of efficiency, outsource that, baby. Outsource it. It makes total sense.
Yeah, and that is exactly the transformation that is going to happen in industry over the next, we could argue the time period, 10, 20 years, as people get comfortable with that model. And as just exactly as you said, they figure out, well, what's the things that I need to keep in-house? Because it's how I differentiate myself. It's how I add value. Yeah. And if there aren't any of them, well, then I'd ask, what is it you're doing that adds value, right?
Yeah.
So that is the key thing. And as a guy that wants to be the provider of those outsourced services, we're trying, we have a number of them that we've rolled out for largely around reliability and energy consumption, as I said, and we're just seeing how the market reacts. And, security, right after that domain expertise and which ones you want to do, security is the next big thing that everybody wants to see proof of, wants to feel comfortable, that's really going to work. It's especially important in the industries we serve, because when you say cybersecurity, typically most people think about theft of intellectual property, like, credit card break-ins at Target or Home Depot, right?
Privacy information,
and they got all this IP, all this credit card information. Well, that is a big part of it, as we just discussed, when they think about security and data privacy. But our industries actually have an even bigger concern. They're concerned that path that was set up for them to send data to you is going to be used maliciously for bad things to come in and manipulate what can be, dangerous processes if somebody with malintent comes in and goes to monkey with them. So they really want to know that whatever you've set up to collect data from them cannot be used for bad things to come in and take over, active parts of their facilities. And there's been a lot more press, on this whole topic lately with discussions about, potential penetrations in power plants or oil and gas facilities and those kinds of things. So security is paramount for these guys, and we put a lot of attention into security.
Yeah, and I want to talk about security. Okay, so we'll talk about it really quickly here. Then I want to go to ecosystems in a minute. But I think what you're describing here is that there's different forms of risk. So we always have to make sure that we draw a line. So technology is for security. Risk management is for business. Now, there's different types of risk. Some of them you got confidentiality risk, and that's what we're seeing a lot when you see the FCC, the FTC involved. They're talking about this information, the PII, the personally identifiable information. But you're bringing up a different type of risk, and that is the risk of integrity and making sure the data is integral, hasn't been modified so that something doesn't go out of whack, something doesn't boil over, something doesn't blow up. And then the other one is accessibility and the risk associated with not being able to actually control your machinery. So I want to talk about security in the context of ecosystems. So it sounds to me that oil and gas, lots of money there. So it sounds to me like they're a little bit ahead than some industries, and we can use them as a bellwether in terms of how, and we've been talking about this, just the outsourcing now, but how we can look at other industries that maybe you're listening to now and thinking about your industry. Well, how is it going to affect my industry? So, Peter, I want to ask you, what about the IoT platform and the ecosystem? And again, platform being the technology to bring all this stuff together, which I'm guessing that Emerson has to some effect, and then the ecosystem, which is effectively bringing together different partners to monetize it. So where are we in oil and gas? And the reason I bring it up is because you kind of triggered it, is with this domain experience, we're going to see platforms and ecosystems that are going to be for specific verticals. So I'm guessing oil and gas, this must be forming today, right? It must be forming around now?
Yes, absolutely. And, going back to one of the things I said earlier, I think a big difference here in oil and gas, they have network sensor infrastructures in place, right? It's not like, a building or a parking lot or, a lot of other, there are networks already in place and networking technology already in place. As I said, that we first came up with this expression around doing that digitally 20 years ago. So there's a lot of data that's already there inside these facilities from network sensors. We're also pioneering new technologies such as wireless, wireless sensors for some of all this other incremental data to power these other applications like energy consumption, because they have to be lower cost and much easier to install than the very critical, typically wired sensors that were put in to control the plant. So when you say IoT infrastructure, I think in a lot of IoT industries, you're talking about, a lot of companies that have come out with, here's my stack for how I have a piece of software that can go on a low power sensor with security, and then how that connects to the internet and how it, kind of the plumbing of how all that connects. In our facilities, a lot of that plumbing is already in place, right? Because it was in place to run it. So what we've been doing, and we call it the Plant Web Digital Ecosystem, we've been partnering with other folks on the plumbing for more around the applications, and especially the connected services part of that. So some of our partners are like Cisco for providing kind of higher bandwidth mobility Wi-Fi inside the facility. Microsoft with Microsoft Azure. So our target platform where we deploy these connected services is on Azure. Okay. Dell is another company that we've worked with a lot just over the years, and they're moving into kind of the edge gateway and kind of local computing side of things. That's another company or partner that we work with. And companies like that are the companies that we find help ease the concerns around security, because these are big, well-known IT infrastructure companies that everybody feels comfortable with already.
Yeah. I mean, not that they're necessarily better from a security point of view, but I can understand, the perception. Now, you have the plant web ecosystem. How about small companies? I mean, you mentioned all the big swingers. Yeah, okay, they're all the name brands, but for an ecosystem to really flourish, you need to have, you need to be able to bring in. A lot of people are listening to this podcast right now, and they're companies that maybe they're just a 1 or 2 man, 5 man shop, but they got some really cool AI, or they got some really cool compression, or they got, something on the analytics side. Are they able to get into the ecosystem? How do they get part of this? How do they get into this themselves?
Well, because the domain we work on tends to be very specific, right? This process industry domain. We know some of the smaller players that work in, or some of the guys that are working on it, and there are industry forums, like there is in all of IoT stuff, where we kind of find each other out. I would say some of the areas where we find smaller guys to work with is sensors. Sensors is a big one, because a big part of making all these applications in the other areas like energy and reliability go is new sensor technology to measure properties that people have not looked to measure in these process facilities before, because they weren't focused on energy. They were focused on running the process. They weren't focused on monitoring the condition of the equipment itself. They were monitoring the health of the process. So there's a lot of, we're constantly looking at and working at with folks that have unique new sensor technologies that can be installed easily and non-intrusively in these facilities to power IoT applications. And in fact, if we really like them, we acquire them. So we just, for instance, we just acquired a company called PermaSense that does online condition monitoring from a corrosion point of view. So corrosion can be a big problem, as you can imagine, in these industries.
Sure.
And, the idea of actually being able to have real-time data about or I will say relevant time, data around, hey, I've done something in my process and suddenly I've dramatically increased my corrosion rate. That's a big risk. People love, that's something that they definitely want to have when you talk about reliability. We have little guys that we've worked with that do have, exactly as you kind of described, maybe unique data analysis and analytics tools. So there's a little startup called Seek that we've worked with that very specifically targets the process industries and how you analyze the data from process industries, and they're guys that came out of that space. So they know the very specifics of the kinds of problems and things that we're looking to solve. Okay. So we pick our partners carefully, I would say, because we're looking for ones that really kind of do understand the domain, and we're less looking for kind of some of the traditional, I'll call traditional IoT, communications and plumbing partners, because as I mentioned, we have a lot of that in place already.
Right. And you do bring up, rightly so, the point that, but I still want to get back on how do people get into this ecosystem, but you do bring up the point, rightly so, that, specifically, and I think almost what you've said in all the partners you've been working with, whether it's corrosion or whether it's this, this analyzing, this analytics company, it's all about analytics to a certain extent within the domain of the process industry. So, I mean, this is going to be something that's going to be differentiating. So we're going to be looking at the analytics has to be very much specific to the process industry. The algorithms, or let's call it the modeling, which we haven't talked about, and the modeling will be used for both the analytics and would be used for the on-site processing, would be very specific to the industry, and the application development, for specific, let's say for these type of environments, will be very specific. So yes, I mean, to get into it's not like you're just going to go in there, and your point is we already got the big guys that cover the basic fundamental stuff. So if you want to join our ecosystem, you probably need to do something very specific. And then on top of that, you kind of have to be experts in our industry. So that makes sense. Let's say you have that. Are these, let's say there's some listeners that are listening to you right now. Are they able to join, or is this a closed ecosystem, an open ecosystem? What's the process for innovation? How are you guys opening up your doors to be able to get, different folks and different companies to be able to help you out?
Right now, I would say it's, just to be frank, it's a by invitation ecosystem.
All right.
As companies think they may have something valuable, they contact me or a lot of other folks at Emerson, and we kind of go through an evaluation with them about what they've got and whether, we think it fits with the applications we're trying to target. And then we go out and do specific applications together. Because frankly, and this I know might be somewhat controversial for some of the more, straight big data aficionados that might be in the audience right now. We haven't had, with the times we've tried to do it, a lot of success with kind of the, what I call the big data, throw it all in, a data lake, run very sophisticated, algorithms on it, and wonderful magic will appear in terms of terrific insights as to what's going on.
Not going to work.
Our approach is far more targeted. I mean, we take known problems that we know customers have been trying to solve for a long time, or even ones that maybe they know how to solve, but they've not been able to spend the money on solving them because they don't see the business return. But yet doing it with this kind of outsource model, we're able to deliver a real business return for them. So we go in with very specific problems that we know we're going to solve. A lot of times we know what the key variables and pieces of data we need to have to fit the models and analytics that are going to help us solve those problems. And then we selectively pick data analytics tools to work on the ones where we don't have real-time data or sensor data, fill in the gaps.
Yeah, that makes total sense. That makes total sense.
The last hurdle is the physical expert, right? Sure, the goal is to take the guy who's got 35 years of expertise in his head, from working on, a particular class, from working on compressors, and, put that guy's head, codify that guy's head into a set of algorithms and analytics, right? Yep, that's what you want to do.
Tribe knowledge, yeah.
Tribal knowledge, get it in there, okay? That's a process, though, to build that kind of analytics set in a particular application class to where it really is going to replace that guy. So as this market matures and as you look at the problem set, there's certain applications where we have made it completely automated and digital. There's others where the process is half analytics, half expert still, sure. And by using the IoT model, what you've done is basically generate expertise efficiency. You're bringing the data to the expert who's in one centralized location and is looking at 5 plants instead of the old model where you flew them around to the plant and said, go figure out what's going on with this compressor.
No, that makes a lot of sense. I'm nodding my head. And there always has to be, there's the analyst and you have the tools. And so, yeah, you can bring in these tools, but it's how you use the tools. It's the models that you develop. It's the algorithms that you choose to work on your models. It's knowing the domain. And that's what you're talking about here. And it's the same thing in the discrete manufacturing world. Whereas, one of my clients, they're doing analytics for discrete manufacturing. And it's this concept of tribal knowledge that we're talking about here is so critical. And so then it's just a question of, is it 1% machine, 99% human? Is it 90% machine, 10% human, right? It's just a line. And what you're saying is right now, the human part of it is super important. And until you codify more and more of it, it's going to continue to be important. But over time, it's going to go down. It's going to go down. Are you seeing that? Is it going to, at some point, to be able to, replace it with AI, or there's still got to be humans involved?
Yeah, that is exactly what I'm saying. You captured the thought perfectly. Is over time that will go down. We're seeing it go down, right? But it takes a while to build all that expertise into these systems. Now, that's debatable. That's a point I've had debated by hardcore data science people who have told me, No. Just give me all the data. In fact, I don't even want to know anything about the domain. Just give me all the data, and I'm going to come back and I'm going to, show you some brilliant insights. Well, we've not really, seen that be successful and repeatable, because the other thing that happens is these processes are so sophisticated that they're constantly changing and adding and being that it is difficult, and they don't have all the data, including all of the classic 5 V's of the big data. We're still not quite able to put that all in the same context, with the software tools, necessarily the way a human can. Okay. Yeah. I always joke that at the point at which the machines really get as good at doing that as humans are, well, that's when, Arnold Schwarzenegger is going to appear in the middle of a parking lot naked, right? And warn us that they're about to take over.
Not today. Let's hope that doesn't happen today. But okay, you mean like the old one, right? Like when he was young. Okay, yeah, that makes sense. Yeah.
And hopefully your audience gets that semi-subtle, reference there as to the dawn of the machines taking over.
Yes.
But that's a transition that's happening, and yes, the tools, the data storage, the computational horsepower we can throw at this problem is order of magnitudes better than it was 10 or 15 years ago, but it's still going to take some time to get to where more and more of these where these problems are codified. I think the medical industry is a great example of that. I look at the medical industry and I say, hey, this is easy for those guys. They have one kind of machine, humans, that they're working on. And you know what? All humans have the same basic set of chemical processes inside of their body, right? So if there's one that we ought to be able to codify in a big data system, should be the analysis of what's happening with people and with health. You look at our industries, there are hundreds, if not thousands, of different processes that vary by what you're making, what type of crude it is in the oil and gas industry, what kind of pharmaceutical you're manufacturing in life sciences. There's a lot of fundamental process variation, that it's difficult to get, to where you're going to have any one of those codified. Humans, hey, there's 4 billion of us now that are all essentially the same. So we should get good at that.
It's a complicated the same, but yes, I understand your point. So I think, if we squint our eyes, the theme of what we've been talking about up to this point in the show has been that the oil and gas industry has been commoditizing those components of the tech and the services that are non-domain specific. And I think, we've latched onto analytics, because if you look at the entire IoT stack, as people call it, then yeah, most of it, you can bring in the big guys or small guys, but you can bring them in and it'll pretty much, if you're just moving bits around and you're trying to secure those bits and so forth, that's pretty much independent of what the bits are underneath. But analytics, modeling, application development, this is when we get into specificity, and this is where you do need the domain experience. And so it sounds like, it's kind of a theme, and what I'm getting from you is that it's oil and gas is a little bit ahead of schedule compared to other industries, because you've had those sensors, and then we can talk about, there's also having these legacy systems is also not always a piece of cake, and it's not always great shakes, but you have that experience, and so it seems to me, with the limited knowledge that I have with oil and gas, that it seems to be a little bit further ahead.
I agree. From a core, because just that core architecture, as I said right in the beginning, that idea of real-time or relevant time data from sensors powering analytics and algorithms, driving actions, well, that's old hat for them, right? That's how they've been running their facilities, okay? And I think you captured and summarized the differentiation areas very well. I would add one. In those specific industries that we serve, we think the sensor technology is also differentiated because in many other industries, they always say, well, you go get a cheap $2 sensor or whatever, you got sensors in your phone, whatever. For the environments that these sensors need to go in, you need sensors that can operate in very harsh environments, right? Think of a platform in the North Sea. They need to operate 24/7, 365. You want them to be wireless and, battery powered. So they got to run for years on a single power source with no plugging them in at night. And they're measuring sometimes some very specific properties that other people aren't interested in, like corrosion, right? I already mentioned that one,
And chemically, then so the chemical sensors then.
Yeah, the chemical sensors in those. So that's probably not, a sensor that we're going to see as a big hit in the, wearables IoT market, right?
Right.
So we do believe, and so we're a big sensor company, so of course we believe this. We do believe that there's also differentiation in the sensors when we talk about industrial IoT for oil and gas and other process industries. But otherwise, the other stuff you hit, yeah, completely agree. It's the domain expertise, it's the applications, it's knowing how to apply the analytics packages, or then the core, computing and plumbing infrastructure, and even I would say to some degree the analytics tools, themselves. Right? There's a lot of them. Some of them are better suited than others for our problems, but we don't see in our industries long-term differentiation from package A to B to C to D. And I might be making people unhappy by saying that, but that is our perspective.
You're saying you're not seeing differentiation?
No, not
Yeah. No, because it's going to be how you're going to use the tools. I mean, they're all it's like a lever. I mean, they're all maybe different lengths, different widths, made out of different metals, but they all leverage. But you still have to know how to use that tool. Is that kind of what you're getting at?
Yes. No. Exactly. Am I going to beat Formula One car race driver Alexander Hamilton? In a Porsche, and he's driving a Ferrari or maybe a car that's 90% of my Porsche. Hell no. He's going to beat me because he knows what the hell he's doing with that tool, right?
Yeah.
So,
I think that's right. And so that's a good point. And I think it's and you're making an important clarification when I talk to analytics. Again, we have to dig in a little bit more. You've got the tool and you got how to use the tool. What's going to be unique is how you do the modeling. What's going to be unique is, it's going to be how you do the modeling, I guess is really what it fundamentally comes down to. And so, no, that's a very good point. And so you will be able to use a variety of, they have to have the core functionality. The tool has to be able to do what you need it to do. But yeah, I mean, because again, they're just going to provide you with a whole bunch of different levers, and you have to choose the right one and or make your own within that environment. So there isn't probably a lot of differentiation. I agree. There probably isn't a lot of differentiation there. But where the differentiation is you could have a company that says, look, we make a plugin, or we make whatever the terminology is. We make a set of software because we know specifically what oil and gas is looking for, and it calls out all the noise. It focuses on these models, these algorithms that we know work very well for the oil and gas, and now you've got a little bit more precise of a tool. I could see that, right? I mean, that could make sense.
Yes, absolutely. And that's why some of the smaller startup analytics guys that we've worked with, that's what they've done, right? So, for instance, they know that in our space, it is far more about time series data than it is about, batch or transactional data. Which in many business applications, it's more about the transactional data.
Sure.
Yeah. So they've gone to, the effort to make sure their tools are much more geared around the time series data. So that's why they're a better tool, for what we're trying to do. Now, does that mean we couldn't get some results with, other analytics tools? Yeah, we could. I still think, like I said, it's the driver of the car is a little more important there still than what the car is itself.
Yeah, and then like we said, we're not sure what that time horizon is. That will change over time, but that driver is still going to be very important I'm guessing for at least our careers, and maybe a little bit longer.
Now, another thought I'd like to throw out there is, as we codify this information, as we get to where we really have built like wonderful, intelligent, complex models that, understand what's going on in a particular piece of equipment or process, 99.5% as well as the best expert did. A lot of our customers has told us that their expectation is that information will get then put back into the on-premise systems. that they won't have to get that information just from like an IoT remote monitoring kind of model. They expect to see that go right back into the system. So if you, again, I'll go back to cars. You think about cars and all the onboard diagnostics on cars. Well, until very recently, nobody thought about actually having cars be connected and, having some remote guy, look at the car and figure out what's going on. Tesla has, and Tesla does. But that industry really focused on onboard diagnostics and how do we make that better? Okay, now they have the opportunity to do those in a connected IoT kind of manner and feed that back to you. Oh, is that the long-term thing people are going to want to see? Or they're going to say, first of all, I don't like the fact that my car is connected because I saw that video where the guy used that connection to hijack the car, exactly my earlier security thing, right? It's fine when they were looking at my gas mileage. I was not so fine when they started taking control of the steering wheel, which is exactly the concerns our process customers have. Sure. Okay. And, I don't want to have to pay for a data connection or whatever. Why can't you just put all those smarts right in the car now that you've built a codified system that knows how to do it?
Yeah. No, that makes sense. And that's just a different type of analytics, right? And so that's just moving it a little bit closer to the data. And I think that's also another trend. And, maybe you're inadvertently saying the same thing, but this processing over time, and of course there's going to be new things that are discovered. And so you're always going to need these people. But this legacy processing over time will move closer and closer to the source of the data. That makes total sense. And that'll make a lot of the fog folks really happy to hear.
Exactly. Well. That will make the fog. And we were just, what we were saying, we were joking the other day, because, you had clouds and then we got the fog. And we're going to do mist. Sorry, we're going to do mist computing.
That is a thing. I don't know if you know, but you need to watch one of my videos, and it's actually called mist computing.
I think that's maybe why we were just talking about it, because we saw that as a concept, right?
All right, Peter, tell everyone listening, where can they find out more about you and Emerson?
Well, they can certainly find out more about us at the website, right? So just www.emerson.com is where they can find out more. They can find out more about me on my LinkedIn space.
And anywhere, and so I'll put this in the show analysis notes, but is there a particular spot on the interweb, on your website itself, that talks about your automation, your plant web, or your IoT?
Yes, there is. We have an actual website around operational certainty by Emerson. I can't remember the specific website, but you can search that and you'll find it.
Yeah, and we'll also, and I'll get it from you, Peter, offline, but we'll put that in the show analysis notes. So anyone who wants to dig in a little bit further, you can navigate your way through the Emerson website, but in addition, we'll have the link that'll zoom you into this stuff. So excellent. I enjoyed our conversation. I'm sure everyone listening in enjoyed it as well. Good luck with things, and I think you're looking at things the right way, and I appreciate your time.
Thank you very much for allowing me the opportunity, Bruce. I had a great time as well.
Okay, that was a good talk with Peter Zornio. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support this show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is Illuminating the Enterprise's Dark Data with AI and IoT with Brett Greenstein. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Till next week, may your path to IoT business be a processed one.
You have been listening to the IoT Inc. Business Show.